So in this video, actually, we are trying to understand how a biological neural works and how it's the growth strategy and how you link the thing in the mathematical concepts. Because if you see the first video of this series of the deep learning, so then we will discuss that some the overview of that the neurons, how it's work and how we'll model that neuron in the mathematical way. So now let's try to understand more deeply. So in these pictures, in that particular reference, I have taken that pictures. So if you just search on Google, simple, just type on biological neurons versus artificial neuron, then you can easily find that kind of pictures. So let's try first understand. So in that particular pictures, I'm not actually a neuroscientist. So so these things are called the dendrites. Dendrites. Okay, just take a little different color. These things are called the dendrites. So the work of the dendrite is that it's take the input, okay, and that part is called the cell body, okay, means that, and also in biological term it's called the nucleus. So in the cell body, some operations, some biological operations are occurs, and in the dendrites, some electrochemical signals are passing through the dendrites. I'm not knowing the details of the biological chemistry here, but some electrical signals are passing through that one, and after passing through that one, some operations occurs here on the nucleuses. There are a lot of more complex things of there, but I am not know anything about that thing, but just try to understand how it's work first. So some functions are, some things are happen on that nucleuses, then after happening something, it passes that signal through the axons, and these same axons as taken as the input to the another neurons. So this is the simple work of a biological neurons. Now the question is how we will trace the things in a form of a mathematical way. That's the thing. So here in biological system, we will take the input in electrochemical signal, but in mathematics, we have not taken the electrochemical signal. We have just taken input as a number. Okay. So now let's see how we will model the thing. Okay, now let's see how the things actually work in mathematical way. So here, instead of a electrochemical signal in mathematical model, we have taken is number. Okay, and based on this number, you can see here in this particular pictures, there have the different thickness of the dendrites here. These are the some little bit more thicker than this one and this one. So these are the thickness. So now here, instead of using the thickness in mathematics, we are taken that term W naught. So the W naught is the more the more weightage of the more value of the W naught, means that we are giving the more priority of that particular connections of that dendrites to the cell body. That's the W naught works here. So in here in mathematical model, it's called our the input, and this W naught we call the weight. Okay, and this is that simply the multiplications, mathematical multiplications of these two terms. Okay, and the simple things, the simple mathematical multiplicative sums are taken here in that particular cell body in our mathematical model. So now let's draw that mathematical model first, better way. So first we have that input signal. In mathematics, we have the input is look like x1, just take different color for better visualizations, x1, x2, x3, like it will be, sorry, xn. So using here your white color, this is x1 input, x2 input, x3 input, like that. I'm taking a n input. Okay, now here for age input, we have make a connections to the cell body. So suppose this green color, light green color is our cell body, is the cell body. Okay, so here cell body, we have taken here that function. There have the two functions occurs here. Suppose, okay, this is our cell body in mathematical model. So here this cell body also called the nucleus in mathematical nucleus. So now here we have give the connections to the cell body first. Make the connections here. Okay, Now here x1, so here connections. So now the question is, what will be the connections in mathematics? So the connections value in mathematics will be the with W. We denote that one. So this connection W1, this connection W2, this connection W3, these connections W4. So the more value, more weight, more W value, so it will be the more deeper connections. So if that value, sorry, if that value will be more and more, then these will be more thicker as the biological neurons. Here we are not passing the electrical signal. Here the thickness depends on the value of the W. So the more value of the W means we will try to understand this thickness of the neuron of that the dendrites. And if that suppose some W is 0 is equals to 0, it's if some W is equals to 0, that means what? That means there have no connections between this input to the cell body. Means there have no this input have no give that so much informations, any information, it's give not any informations to the neurons. So for that reasons this weight value will be 0, means there have no connections, simple. So after taking that one, so in the nucleus we have make some sum operations, multiplicative sum operations we have made. So what is the multiplicative sum operation? Let's see it. So multiplicative sum operations is look like that. Here first we will multiply age x1 to the xi to the wi. So let's see. So here this information, this multiplicative sum will be x1 into w1 plus x2 into w2, like that way, xn wn. So in simple we can write that form like a this way. So xi wi this way. So here I will be 1 to n, as we have taken here the input is 1 to n. So after making that multiplicative sums, we have used that thing, we have used these functions, past functions through a functions. So I am used that this color for the to this color I have used here to define that function. So suppose we have used a function f. So as time progresses, we will see what will be the characteristic of the functions, what type of the functions we will use. So these are called the activation functions. These functions are called the activation function. These are called the activation functions. So now after taking that multiplication, we will pass that value. We will pass that value to that functions, and we will get that taken this, and these things are called that output. Okay, now this output, after taking this thing, after taking this one, now this output we will pass to that another neuron, this called that output. We'll pass this output to the another neuron. Here some neurons are there, here some neurons are there. Okay, some neurons are there, we'll pass. So this structure is called a simple perceptron, a simple single neuron structure. And when these things occurs, we will call these things occurs, we will call that the neuron is fired or is activated. When this structure is called, when these things called, we will call a neuron is activated or it's called a sample, a neuron fired. Fired is simple, it's a biological term. In the neuroscientist, in a biological in biology they are use that term fired when the electrochemical signals are occurs and some things occur and some things happen on the cell body, and after that it passes some output, some electrochemical, some electro signals comes, some things occur onto the cell body and some output given. This is called that fired, but in our mathematics, in our artificial neuron, we will call that is activated when these things occur. So this is the simple structure show of a single neuron. So in simplicity, if we write that thing, in simply we write that thing in a single functions, then we can write that in that way also. So a output of a neuron is written as a some activation functions of the multiplicative sums of what? Multiplication sums of weight and corresponding input. Okay, and these things are called the weight, or you can think like a connection, and these things are called the input, weight or connection. Okay, and as time progresses we will see a simple logistic regressions, because when we are learning the classical machine learning algorithms, then lots of theorem, lots of classical machine learning algorithm we have learned already. Now we will try to understand through that structure how we will understand this classical machine learning problem to that simple structure. As time progresses we will see the things. Okay, and these things are called, and these simple things are called a equations of a perceptron. These simple are called a equations of a perceptron. Okay, and this structure is a very old structure, but as time progresses, as our computational power progresses, we will more thing are added, more complexity are added here, but it's the simplest structure. This is the primary structure that we have to understand before going to that part. So it's that come into our pictures in 1957. So you can easily it's research paper is easily available on internet. Just even search, then you can find here. Now the second part is coming to that thing, how a neuron growth as time progress. As time progress means as our age progress, as a human are matured, then how it grows and how the structure changes, how the things are happening. Now let's try to understand that part. Okay, now before understanding the how a human biological system, biological neural network system growth, so first we have to understand what is a neural network. Okay, so neural network means it's simple thing, it's a connections of multiple neurons. So here we will understand what is a single neuron. Now the network of a neuron is called the neural network. Okay, so it's the simple, it's connections of multiple neurons together. So simple, it's a connections of multiple neuron together. So let's see how it's look like. Suppose it's a single neuron, some inputs are coming here, come from different neuron, and some outputs are given here. This is a one neuron, this is also, and these connections also coming from this side and this side, like that. So simple, in an ensemble neuron it has some inputs and some outputs are there. So this is this type of structure, network structure, are called that neural network. So in biology, in our human, there have that biological neuron connections, that's called that the new biological neural network. And but in our artificial intelligence, means the in machine learning, we will, the connections are called that artificial neural network. That's the main thing. So now let's try to understand. So that the thing is a simple, it's that just little bit zoom that picture, then it will better to visualize. Let's little bit zoom it. Okay, I think now it's okay. So in the picture, actually I have taken from that particular references, just type on the Google image the neural connections of a human as time progress, just type that type of thing, then you will easily find that picture. So in the pictures, actually you will say this is a small portions of a human brain, mainly it's the cerebral cortex. Actually if you know something little bit about the human brain, there you have the some portion that in that human brain there have the lots of portions. So in the front portions is called that the cerebral cortex. So in the small portion, the little bit small pieces of uh, places that taken, and just if you just visualize it through microscope, then you will see that structure of the neuron on that particular cortex. And this study are in a very old study, in 1959 this study is actually occurred. So in that one, when a baby born, so they are have a little, means they have no connections. This is one neuron, this is one neuron, this is one neuron, this is one neuron. So they have no any connections between the neurons. So but as time progress, when you can see as time progress, when the birth is happen, there are no connect, simple, it's neuron is there, but they have no built any connections. So but as time progress, when it's the 6-year-old, then you can see how much connections they have built, how much connections, because why, we'll see. And then after 14 years, then you will see the connections are reduced. And why this also reduced? So now let's see, let's try to understand. The thing is that when the baby is born, they are have no any connection, any type of learning mechanisms. But when time progress, so they try to understand the thing, they try to thinking process are developed, they try to visualize various things, there are lots of sensors are working there, and they will feel the touch, something like that. So on that particular thing, so they will come into a learning phase. So the thing is that from here to here, from this phase to this phase, and this phase to this phase, learning mechanisms are coming into the picture. Learning mechanisms. Now, what is actual learning? What is learning? So learning means what, that we in human will understand. Learning means that the power of understanding. And what is this means that think, feel, emotions, like that kind of things are called that learning. When we developed our learning mechanism, then this type of intelligence it occurs into our mind, or something into our human, in human psychology. So here the learning mechanisms are simple. It's like a the connections between the build the connections in biological term. Simple, the learning means, if I write it, learning means the simple connections between the neurons through ages. Connections. So you can see in the blood they have no connection, but as age progress, so they have lots of connections are built. So the learning is simple. In simple, we can call it as a connections between neurons with ages. This a simple thing of a learning mechanism. These things are called the learning. So how much connections we can build between the air, so that much learning we can happen. Now the question is, why these connections are, if we learning as time progress, why as time progress then these connections are reduced? So you will think that thing in practically. So if we learn something today, after something, after 1 year 2 year, we'll try to forget the things. Because why? Because as time progress our connections are reduced. So why connection are reduced? If we build so large amount of connections, so to survive that connections, we need lots of resources here. We need lots of energy, lots of foods to supply to make that energy. So but in human structure they have lots of, they have the limits of some resources. So the body human structure is built such a way that the unnecessary connections is automatically reduced. Okay. And the connection that you will see here after 6 years to 14 years, the connections are here. So the thick connections means they have the more, these connections are staying here, that gives us the major role in our thinking process. So you can see here, this is, and this is the most of the thicker connections are staying here. So that's totally depend on our environmental situation, in which environment we are taking that, we are taking that learning mechanisms. So that things are totally dependent to build that connections. So if we just try to understand this more better way, so when we are making the learning mechanisms, we are coming to the learning mechanisms. So on that particular time, we will on the particular time we will what kind of learning we are happen in that age of 16, like language. We are trying to understand various type of language that depends on our environment. So then also speech, we are trying to speech, and object, try to detect the object, and also some emotions are there, some feeling are there, some sensors that is going to be sense, some sensor are activated on the particular learning pages. So here on that, because of that reasons, so to understand that learning, so we will build that connection. They will build that connections to make that, and to staying that. to survive that connections, we need, okay, to survive that connections, we need more, to survive that connection, so we need the calories to survive that connection, calories. Okay, but due to the limited of that resources, so due to connections, so it will try to reduce, it will reduce, it will automatically reduce. And how the way will reduce, that it will be reduced in such a way that will automatically adjust to our environment. It will, it depends on our environment. Okay, so this is the one simplest way how it's growth and how it's reduced. It's totally depend on the situations, and it's our environment, how the learning learning mechanisms occurs. So one thing you will notice here, so suppose uh, at the age of 6 years I will grow in an environment. So here, based on that particular environment, our connections are built and reduced time to time as time progresses. But after some time, we'll move to the another phases, another environment. So on the particular environment, also some new things we will learn. Means some new connections also built there. So on that new environment, we will forget our old environment system, some things. So on that particular things, automatically the old environment that is not necessary on that particular environment will automatically reduce there. So because of that reasons, because of the connection, new connections built, and new connections and the built connections are weaker. Means that it is connection is totally not connected, but it's making the weaker connections. So because of that reasons, our learning mechanism, in our learning mechanism, we will forget something and we will remember something. But because of simple that connects things, because of the making the connections between the two, between the neurons, how much strong the connections is, the connection is more strong. Because of that reason, so we will remember that thing more much way. But the connections is weaker, that means that we will going to forget that thing. So it's depend on the situations, which environment. So it's totally depend on the environment, it's totally depend on the practice, it's depend on the our situations. So these connections, so these connections are is not is not a constant, it is a variable way. So it depends on the situations, it depends on the signal, it depends on the input and output. Okay, so if we just make the summary of that thing, so according, so connection is what, so sorry, the connections is the learning, the simple learning is that what, learning is the connections between the neurons with ages. So and one thing, according to the our data, according to our environment, these connections are formed as increased, as in increased. So we can write also here, according to the data, or you can think like a environment, or like a, you can think the situation. Both are the different term, but in the meaning are both the same. So these connections are formed as age increased, or you can think time increased, as time increased. Okay, this correction from such a way. So and this connection that the connection that I am talking about, these connections are built in such a way. So there have some technique. If these connections are yeah, formed such a way that a human, or you can think a kid, can survive the environment. Human or kid or any animal, that's same thing. Any animal like that, the neurons are there, can can survive the environment. So it's totally the it's not a constant thing. The connection means the learning mechanism not a constant thing. It depends on that. It as time progress, as time change, its formations and that its reductions are happening. It's that thing. This is not a constant, it's a variable thing. Okay. So this is the simple thing how it's work and how the growth actually occurs of a human. I think you will understand all the things. So just summarize all the concept here that we have learned. All biological learning is nothing but it's a simple. Let's take a different color. All biological learning, if we just summarize this lecture in a single word, all biological learning is nothing but simple. It's a connections the weight on between neurons. Sure, it's the learning is that neural connections to weight. Connection between neurons through some weights. Okay, and these things are we will see in artificial neural network. Instead of the weights in biology, it's that use that the thickness of the dendrites. Okay, but in our artificial neuron, instead of the thickness, we will use that number. That number is called that simple weights. Okay, so or in another language, you can call that thing learning is just generating the weights between connections. And this generating of the connections are totally depend on the data. Means I'm talking about data means here the environment, the input, the things. Okay, that is nothing, just the inputs of the, it's totally generating the connections. It's totally depends on the, sorry, it's totally depends on the input. Or you can think like a data, or you can think like a environment, or you can like think a situation. All the things in machine learnings are generate data, the data, nothing else. Okay, I think you will got some little about the concepts, how the neurons work and how a biological neural growth system occurs as time progresses. Now in the next video we will see how a logistic regression model, we can generate a logistic regression model through the neural networks, because already we have learned how the logistic regression models works, but in next video we'll see how to reform that logistic regression. The same concept, same thing, but we will see the concept in the point of view of that neural network, the geometrical concept in the point of view of the neural network. Okay, we'll see that in the next video. So if you have any doubt, any questions, please comment below. I am always here to help you. Okay, till now, bye.